graph the shape? Yeah? It's nice. Up, over, and at an angle. So what are our vertices? 0, 0, 1, 0, 0, 0, 2, 0, and 0, 0. Oh, did I do that? That's Z, isn't it? Oh, man, I got to be careful, shouldn't I? That's 3. So this one should be 3, and the other one should be 2. So right about here. Is this the tetrahedron? Oop, I can almost connect the dots here. Is that cool right there? Is that the... That looks like it. Was it 1, 0, 0, 0, 2, 0, and 0, 0, 3? Nice. So we have to find the bounds for the triple integral, correct? Yeah. This is actually, is this relatively a nice shape? Yeah. This is relatively a nice shape. Okay, so first of all, so we know we're going to fill in the blanks on some sort of integral that looks like this, where what is it, x, y? And for dv, since it's such a nice tetrahedron, you could actually do this. How many different ways could you write the order of integration on this one? There's 6 different orders, right? What's the standard one that you really like, though? dz, dy, dx. You really like them. On this one in particular, it wouldn't be very different to do all 6 of them. Do you want to do all 6 of them? Not really. Let's just do one, okay? Let's just do one. So first of all, for dz, dz is not bad because you know it has to go from 0 to the ceiling, right? The problem is you have to come up with the equation for the ceiling. Why did we need to determine that? What are we trying to isolate now? Or what do we want to isolate from this green one? We want to isolate the green one right here. So what do you end up with? Z is equal to 3 minus, we divide by 2, 3x minus 3 over 2 what? 3 over 2y. So where does that go? In the limit. So we have 3 minus 3x minus 3 over 2y. So we just found the limits for z. That's correct. Now we need to bound y. And what's the only variable we can use to bound y? X. So what line do we need to find the equation for? You need to find the equation for this line right here, correct? That one goes down 2 over 1. So what's the slope of that thing? So it's y equals negative what? I'll use a different color. Y is equal to negative 2x plus what? 2. So y goes from what to what? 0 to negative 2x plus 2. And what's x bounded by? 0 to 1, right there. There it is. So what's your first step in setting up number 12? What's the first thing you should do? Draw it. Like actually draw a picture of it. It's a tetrahedron, so it's not that bad. So draw me a picture, and then we'll clip it in. There we go. We can do it, dz, dy, dx. We're going to do it. So what do we, and first of all, did it put something in there? Yeah, put x, y, right? So we're going to do dz, dy, dx. So first of all, what's the x bounded by? The x is easy. 0 to 1. Let's work backwards here. Now y, what line do we have to find the equation for? We have to find the equation for this, right? It's actually kind of easy. What is it? Y equals x. So this thing goes from 0 to what? Oh, sorry, excuse me. Goes from x to 1. That's correct. Now this dz, the z is the one that's going to be a little tricky. We found out the equation of the upper plane, so what do we need to isolate? Z is equal to y minus, so we have 0 to y minus x. Is this one a little bit better than the one we just did? Yeah, it's a little bit better. The function we're integrating is better, and the limits are a little bit better. It was a little, I think, tiny harder to find out, and I think it might have been easier finding the plane this time because we had a little practice. It's 0 to 1 again, and it's 0 to 1. Why? I got to stop saying why. Because you're going from here to here. Sorry, there's the picture right there. Okay, what about z? What is z going from? You have to be really, really careful about this. Where z, right? Z goes from 0 all the way up to here, right? So it's going from 0. Now, what's the equation of this line right there? Z equals y. Z equals y. So this is going to have to be written in terms of y, so it goes from 0 to what? 0 to y. It kind of makes sense there? And now, this right here is limited by the plane we already determined. We did the work for the plane already. But what do we need to isolate instead of z? So x is equal to y minus z. So it goes from 0 to 0 to what? Y minus z. We haven't done the x equals z bound, right? And that, if I try to draw the x equals z, it goes like this, right? But the problem is, it's going to muddle this up. So I'm not going to draw it right now, but I'm going to include it in the integral. So this one nicely, the projection goes down. And this is actually, what type of region is this yellow region right here? It's a type 1. Do we like type 1 regions, Tony?
Yes.
We do? Okay. So we have triple integral. And what are we integrating on the inside? X plus what? 2y. Shh, in the back. So we liked dz, dy, dx. What's the dz bound going to go from? This is easy. It goes from 0 to what? 0 to x. It goes from 0 to x. And then what is y bounded by? What's the upper y boundary? The red line right here. What is that?
X, y equals x.
It equals x. So the upper boundary is x. What's the lower boundary?
X squared.
The x squared is the lower boundary.
Yeah.
And then x goes from 0 to whatever this intersection is. Well, that's the intersection of y equals x and y equals x squared, which is 1. There it is, right there. You just did the entire thing. So it continues up and down. What about z equals 1? Where's z equals 1 going to be? So basically we have a boundary plane like this at the bottom. Right there. So it starts there. And the planes z equals 1, which we got. So we have this and this. Now you just have to graph y plus z equals 5. Okay. Because you have a square root, yeah. So you have the triple integral here. And what it goes on the inside, it was, just solid, right? It doesn't matter. So it's just going to be dz, dy, dx. Because you're just trying to find the solid enclosed. Okay, so the first is z. What's the lower bound for z? 1. How do you find the upper bound for z? 5 minus y. Okay, that's friendly. That's nice. Now what about y? We know that x squared plus y squared is equal to 3. So y is equal to plus or minus the square root of 3 minus?
It's 9.
Oh, is it 9? I'm just thinking of the radius in my head here. So it's 9 and 9, right? So which one's the positive one? Well, which one's the upper one? Excuse me, that was said really poorly. Which one goes on top? Yeah, the positive 9 minus x squared, and the lower one's going to be 9 minus x squared. And then what is x going to do? I think it's negative 3 to 3. So that's kind of nice, but then what happens? It becomes really, really nasty once you try to integrate this. We're going to convert to polar. Yeah, so what do you end up with? 1 plus 4 times e to the negative r squared times... Oh, it's r squared inside there. Thank you. Times what?
R squared.
Like this? And then what does dA turn into? R dr d theta. Do you see that little hook that I put at the end of my radical sign right there? I really like that, putting that there. And then the question is, what does this turn into? Well, it's 0 to 2 pi. And what's the radius? 0 to 2. Is that actually a pretty nice thing to integrate? They say this. Well, I'll show you. They go 0 to 2 pi of d theta, and then 0 to 2 of this thing right here. And that's r dr, like that. That's what they do.